All right, in this video, we're looking at section 9.3. We're looking at trig functions of an angle using reference angles. Yay! At the end of this lesson, our learning target will be met and you will be able to find and use a reference angle to evaluate all of your trig functions. So let's explore the idea of a reference angle. So the reference angle is going to be formed when we have an angle theta, but reference angles are only in quadrants 2, 3, and 4, okay? So let's say we have some angle theta, and it's an angle that's measured in standard position. So let's look here at this angle that's in quadrant 2. So theta starts on the initial side and opens up to this terminal side here. The terminal side is in quadrant 2. The reference angle is going to be an acute angle that is formed by the terminal side here and goes towards the x-axis here. So this angle measure here, from the terminal side to the x-axis, this measure of this angle is what we call the reference angle. And it's referred to as theta with apostrophe, and so we call it theta prime, theta prime. So the relationship is shown here for quadrant 2. If we look at quadrant 3, if our angle theta is in quadrant 3, so it's opening up all the way and the terminal side is here in quadrant 3, in order to get the reference angle, we're going from the terminal side up to the x-axis. So there's our theta prime, that's our reference angle. Likewise, if we're in quadrant 4, our terminal side to the angle is down here in quadrant 4, so we're going all the way around to quadrant 4. In order to find the reference angle, we're going from the terminal side up to the x-axis here. All right, so now let's look at some examples where we're finding our reference angle, theta prime, for theta values. So the first thing we should do is graph out what the angle measure looks like. So if we have angle theta here as 15 pi over 16, so it's 15 pi over 16. Well, that's pretty close to 16 pi over 16. 16 pi over 16 would simplify to just 1 pi. So it's actually all the way around here, a little bit short of that x-axis, the negative x-axis. So this angle measure right here is theta. So if this is theta, the reference angle in quadrant 2 is going to be here from the terminal side to the x-axis, and this we're going to label as theta prime. So if we go from here all the way around to here, we know that the angle measure at the negative x-axis is pi, right? So 1 pi, so this is pi. So in order to get this angle measure, we need to take pi and subtract 15 pi over 16. So 15 pi over 16. So we could simplify this and write this as 16 pi over 16. That's 1 pi minus 15 pi over 16, which is our angle measure theta. And so when we subtract, we end up with 1 pi over 16. So that's our reference angle. So we're going to write theta prime is equal to pi over 16. That's the reference angle. All right, so let's look at our next example. Theta is equal to negative 220 degrees. So we're back to degrees with this one. And I encourage you to go ahead and pause the video, draw out the angle, and identify which quadrant the terminal side for this angle is in. Hopefully, as you're drawing out your angle, you are realizing it's negative, so we're going clockwise with this angle. So we're passing negative 180 degrees, and we're here in the second quadrant. So this angle theta is equal to negative 220 degrees. And so let's look for our reference angle. So we said our reference angle will be the terminal side of the angle to the x-axis. So here is theta prime. So we're labeling that out as theta prime. On your homework, in order to get credit, you need to label the initial angle, theta, as well as the reference angle, theta prime. Make sure you're labeling these. You can actually even write the values also. Okay, so to get our reference angle, So in order to get our reference angle, it's important to note that a reference angle will always be a positive angle measure. So since we have a negative angle for theta here, you could consider this just as a positive angle, right? And if this is 220, you could subtract off 180, and that'll give you theta prime as 40. Another way to think about it is think of a coterminal angle, positive coterminal angle for theta. So pause the video, come up with a positive coterminal angle for theta. Okay, hopefully you came up with plus 360 degrees. So the positive coterminal angle for this is 140 degrees. So a positive coterminal angle right here for theta. So this is a coterminal angle, it would be 140 degrees. If this angle measure here is 140 degrees, that tells us that theta prime is 180 minus 140 degrees. So we're going to have 180 degrees minus the coterminal angle of 140 degrees. And so we get theta prime is 40 degrees. Okay, so here we go. Let's evaluate trig functions. And the reason why we looked at reference angle previously is if we look at a reference angle, we're able to figure out any of the 6 trig functions that we've talked about and evaluate them for some angle theta, where angle theta is not an acute angle. So the process is this, so I encourage you to copy this down in your notes. For step 1, we're going to find the reference angle theta prime, okay, just like we did in our previous examples. The next step, we're going to evaluate the trig function for theta prime. And then we're going to lastly determine which sign for the trig function based upon the quadrant in which angle theta, the original angle theta, lies. Okay, so before we jump into some examples where we evaluate trig functions, let's look at the signs for the functions. So we can see in quadrant 1, all of our trig functions are going to evaluate to be positive ratios. Okay? In quadrant 2, the sine and cosecant functions are the only 2 that are positive. All right, in quadrant 3, we see that the tangent function and the cotangent function are positive. And lastly, in quadrant 4, we can see that cosine and secant are positive. So an easy way to remember this, because we're in math, all students take calculus. There you go. So you'll remember which function is positive in each quadrant. Okay, so let's find the cotangent of negative 210 degrees. Okay, so the first step, let's draw what that angle measure looks like. So we're negative angle, we're going clockwise. So here is the angle theta, which measures negative 210 degrees. So we're up here in quadrant 2. We passed negative 180 to negative 210. Our reference angle, let's label it. Here it is. Here's theta prime from the terminal side to the x-axis. In order to find the measure for theta prime, I'm going to look at a coterminal angle to negative 210. That's a positive coterminal angle. So how can I get a positive coterminal angle to negative 210? That's right, we're going to add 360 degrees. So we're going to add 360 degrees and we end up with 150 degrees as a positive coterminal angle. So this angle measure here is our positive coterminal angle at 150 degrees. In order to get theta prime, the coterminal angle and theta prime will add to 180 degrees. So to get theta prime, we're going to take 180 degrees and subtract 150 degrees. And we end up with 30 degrees for theta prime. Okay, we've calculated the reference angle as step 1. Our next step is to look at the trig function and evaluate using our reference angle, which is 30 degrees. So we're looking for the cotangent of 30 degrees. Okay, so we're going to set this up. Cotangent we know is 1 over tangent of 30 degrees. We also know that the tangent is the ratio of sine to cosine. So this is actually 1 over the sine of 30 degrees divided by the cosine of 30 degrees. Okay, and I'm going to continue to simplify this. It's a complex fraction here, so I can change this to the cosine of 30 degrees divided by the sine of 30 degrees. And that's going to give us the cotangent of 30 degrees, which we'll evaluate to the same thing as the cotangent of negative 210 degrees. All right, so 30 degrees is a special angle. If you have your unit circle filled out for your first quadrant, the angle measure, the special angle measure of 30 degrees here, you're going to have a point on your unit circle that has square root of 3 over 2 for the x value and 1/2 for the y value. So cosine, we said, is going to be our x coordinate. So this is equivalent to the square root of 3 over 2. And we're dividing it by the sine of 30 degrees, which is our y value, which is 1/2. So when we divide this through, we have the square root of 3 over 2 multiplied to 2 over 1, and we end up with the square root of 3. Okay, so that's our second step. We've evaluated our trig function with our reference angle, and then the last step, we need to take a look at the sign for the trig function. So if we remember, all students take calculus. Our original angle theta is in quadrant 2. So this is in quadrant 2. Okay, so in quadrant 2, only the sine and cosecant functions are positive. So the cotangent for negative 210 degrees is going to be negative. So this is the value for it, but we need to write cotangent of negative 210 degrees is equal to negative square root of 3. Okay, the next function that we're looking at is the cosine of 10 pi over 4. So in order to draw this out, 10 pi over 4 is greater than 2 pi. Okay, so 10 pi over 4. If we were going to subtract off 2 pi, right, 2 pi is equivalent to 8 pi fourths. So when we do that, we end up with 2 pi over 4, which simplifies to just pi over 2. So 10 pi over 4 is an angle that goes all the way around and then stops here at pi over 2. The reference angle then, it's just this pi over 2 angle. That's our reference angle, that's theta prime. So we're looking for the cosine of our reference angle, theta prime, which is equal to the cosine of pi over 2. Now remember, in a unit circle, this point right here at 90 degrees, we've looked at this already, the x value is 0 and the y value is 1. So we said that the cosine is always going to be our x value. The cosine of pi over 2 is just equal to 0. So since our original function, the cosine of 10 pi fourths, is right at the end of quadrant 1, so the cosine of 10 pi over 4 is equal to 0.